He compared it to the way pushing on a car's gas pedal makes the car go faster and faster. When a bank adds interest to a savings account daily and recalculates the amount, the total in the account grows. And so if it recalculates and grows every day versus every month or every year, then your money will grow faster if it's being calculated and compounded every single day. So daily compounding, the more often banks compound interest, the more potential you have to earn more interest. So out of those three options, daily has the largest potential for earning you more money over time. Many banks offer savings accounts with daily compounding. Um, when they compound interest daily, it is computed each day and added to the account balance. The account will earn interest from the day of deposit to the day of withdrawal. You can use a table to calculate the amount and interest for daily compounding. We're not going to be using a table. Well, we will be using a table, but I'll show you which one it is. So that's when we get to those types of questions. So it says, suppose, here we go, example one. By the way, we're using the same formula that we had yesterday. We're using the amount equals the principal multiplied by 1 plus the value of R, which was the interest rate divided by how often things compound in a year, and then to the n power, which is the number of compounding periods in total. So same formula as yesterday, compound interest formula. And so our first example says, suppose you deposit $8,000 into an account that pays 5.5% interest compounded daily. How much interest will you earn in 31 days? So the first thing that we need to know in order to do daily compounding is how many days there are in a year. So somebody just type that in real quick. How many days are in a year? Somebody tell me, because that's going to be important to this. Good, 365. So there are, that's going to be a really important part of this lesson today. So 365 days in a year. So if you forgot about that, unfamiliar with it, there it is. Make sure you have that. All right. So we're going with $8,000 in an account that pays 5.5% interest compounded daily. So finding out the amount, or how much interest will you earn in 31 days. So we have to get the amount and then subtract the original principal 8,000 from the amount in order to get the amount of interest. So the principal value is equal to 8,000. That's the original amount. Our R value is going to be equal to 5.5% interest, which is 0.055 over the number of compounding periods per year. And since it happens every day, there are 365 compounding periods per year. So 0.055 over 365. You're going to see this denominator a lot today. And then the value of n is the number of total compounding periods, which it says right here is 31 days. So that means that n equals 31 because it's compounding once a day for 31 days. So we're going to be looking at the exact same formula that we saw yesterday, like I mentioned, and yeah, it'll be the same type of math. We're just going to be using really large values today, essentially, versus what we saw yesterday. So the amount in the account will equal the original amount, 8,000. Oops, I don't need a parenthesis there. 8,000 times 1 plus the interest rate, 0.055, over 365, all to the n power, all to the 31st power, right there. And so I've got somebody typed in an answer already. They said $8,037.45. Well, I'm guessing that's probably correct. Let's see. So we're just going to go back to the Desmos calculator here. And I'll share that over as well so we can see what we're doing here. And it's going to be 8,000 times, oops, not 8,000, 8,000 times 1 plus, we've got our fraction, 0.055 over 365. That's how many there would be within a year. And then a to the b power N equals 31, and nicely done. That was the correct answer. So $8,037.45. All right. So what I want to do next, before we take a look at the next problem or anything like that, I just want to do a comparison real quick so we can see what happens. But let's get the answer in here. So we got the amount equals $8,037.45. Now this particular problem, it did tell us to calculate the interest. So all we have to do is take this number, subtract the 8,000. So the interest earned over 31 days is $37.45. So there's our answer right there. So $37.45 is the answer to the question because it wanted the interest. So we got the amount first and then subtracted the original from the new amount. Now, I'm going to do this same problem. And what I'm going to do is compare it to these three things up at the top here. But instead of 1 month, I'm going to go with a full year. I'm going to use these same numbers, but I'm going to use an entire year. This is not something that I need you to write down, but this is just an example of what happens when you go with annual, monthly, or daily compounding. All right, so we had our principal value equal to 8,000. And that's really the only number we're going to be able to keep the same for all of these because annual means that it only compounds once a year. So the R value for annual is going to be just the rate. So 5.5, and it's at 5.5%. So an annual would be the amount will equal the 8,000 times 1 plus 0.055 over 1, or just because it's only compounding once a year. And it's for 1 year, and so that would just be to the first power. That's basically just simple interest for this first one. And then for monthly, the 8,000 times 1 plus 0.055 over 12 in 1 year. So that's how many times it would compound in 1 year. And if it's for a single year, that means it's going to compound 12 times total. And if it's every single day for an entire year, times 1 plus 0.055 over 365 for an entire year, so 365 days. So these are our three different options here. And what it told us earlier is that this one will give us the most amount of money because every time it compounds, you actually get a little bit more money when that happens. And I'm just going to do this on my personal calculator instead of Desmos this time. So let's see, 8,000 times 1 plus 0.055 to the first power. So after a year, if it only compounds one time, if it's an annual compounding interest, it's $8,440. Now, if it compounds 12 times in a year, once a month, that's going to be 8,000 times 1 plus, now we need a fraction, 0.055 over 12. And that's going to be to the 12th power. And we're looking at $8,451.26. So it's $11 more a year if it's compounded monthly. Let's see what happens with daily. 8,000 times 1 plus fraction 0.055 over 365. And it was an entire year, so it'll compound 365 times. And we're looking at $8,452.29. So you can see over the course of a year, the more often it compounds, the more money you end up with. Now, it's not a huge amount more, but If you're talking about savings or kind of like I mentioned yesterday, retirement, um, if we're talking about a retirement account, this number is likely going to be bigger. You're likely to be contributing more, which means that every little bit counts, especially if you continue to put more money into it. So daily compounding interest is definitely going to earn you more than monthly or annual. So that's just a comparison of the exact same amount of money, the exact same interest rate. It just compounds more often, meaning your interest is earning more interest over the course of that year. So that's just a quick example with that. All right, let's head back to our notes here. Take a look at some other examples. So number 1 says that Ramona owed and deposited $6,000 at 5.5% interest compounded daily for 25 days. All right, so the principal amount, 6,000 R, is going to be, actually it's going to be exactly the same as the one we did on the other side over 365. And then N is 25 days. So N is 25. For number 2, principal value, 6,000. And same interest, again, interesting. They're going to 5.5% a lot here. Actually, I think everything on here is 5.5%. That's interesting. That's for 31 days. Okay. So we got a couple different examples here. So this will be kind of interesting as well because, well, there's 2 parts here. Find the amount and the compound interest. So basically, the formula will give us A, and then subtraction will give us the value for the compound interest for B. And really all we're doing here is the exact same principal, exact same interest percentage. We're just talking about 6 more days of compounding between these two. So this one should be a little bit higher than this one here. So let's find out. I'm just going to stick with my handheld today. So A, I'm going to go with 6,000 times. It's always a good idea to continue practicing writing these equations. And to the 25th power. All right. So 6,000 times 1 plus fraction 0.055. And 25. All right. Good. $6,022. And so part A, $6,022.64. So the interest is equal to $22.64. So there's part A and B for problem number 1. For problem number 2, 6,000 times 0.55. Everything's going to look exactly the same except for the exponent, 31, as opposed to 25. So I'm actually just going to highlight this whole thing and change this to 31. Make my life a little bit easier and go with $6,028.09. Perfect. Which means we're looking at interest equal to $28.09. So basically, 6 more days earned about $5.50 more. Just for having the money in the account in the first place, that's kind of convenient. All right, so that's basically what you're going to do if it tells you how many days to calculate it for. N will be the number of days that you plug into the exponent. The denominator of your fraction is going to be 365 because we're talking about compounding every day. So that's 365 compounding periods per year. Now, when we get to example 2, this is where things get a little bit different. It says, on May 31st, Dolores Cowdill deposited $1,000 in her savings account, or in a savings account that pays 5.5% interest compounded daily. So, all right, well, I guess we're going with that 5.5% again. So principal, 1,000. R is equal to 0.055 over 365. This is getting repetitive. And then N, So she deposited on May 31st, and then on July 1st, how much interest had that principal in her account earned? So we're looking for the value of I again, but now we aren't told how many days. So what we need to do is we need to go to Google Classroom. And we need to use, I put something into the notes today that you're going to have to use, and it's the Appendix A10 elapsed time table. And this will tell you how many days have passed between 2 days in a year. So this is how it works. Let's see. We've got days in a year, right? So for example, day number 1 of the month, these are the days of the month over here. And then you've got the months here. So January 1st is the first day of the year. If you want to know what, let's say, July 17th is, so here's July over here, and then the 17th is here. So if you go over to July and then down to 17 on the day number, July 17th is day 198 out of the year. Now, we're going to be basically comparing, it says May 31st and July 1st. So May 31st is way down here. That is day 31 of the month, which is day 151 out of the year. So day 151 from May 31st. July 1st is day 182. So May 31st is day, what do we say, 151. I'm going to use this. I'm going to do this in red and switch it back. So, and then 182 for July 1st. Okay. All right. So that's how we can use that table. July 1st, as you can see, July 1 over day 182. May 31 down here, go to May, that's day 151. So I'm going to head back to the screen share here. May 31st is day 151. July 1st is day 182. So we just find the difference, 182 minus 151, and we're talking about 31 days. So that's how many days it is between May 31st and July 1st. 31 days between those two, a full month essentially. So n equals 31. So that means on some of these problems, I've got a paper copy of this as well. On some of these problems, you will need to use this table to find out how many days that have gone between two of the dates that it gives you. So if it doesn't tell you how many days have gone by, and it just gives you dates, you have to use this chart to figure out how many days there are in between the two dates that are given to get the value of n. So definitely refer to this appendix that's posted in Google Classroom. So make sure you're using that. All right, so here we go. A equals 1,000 times 1 plus 0.055 over 365. And we said that n equals 31. So it's going to be looking real similar to what we've done already. And there we go. So the amount, $1,004.68, but it's asking how much interest had the account earned. So we need to know what I is. So that's just the difference between those two. So it's $4.68 earned in interest. All right. So now that we've seen that, we can try these last two. And once we're done with those, we're done for the day. And we're done for the unit, in fact. We'll start in on our unit review probably tomorrow, but I'll take questions on homework tomorrow as well. All right, so determine how much interest the principal each account earns. So we're solving for I on these two here. So March 3rd. On March 3rd. So March 3rd. So here's March, here's 3, that's day 62. March 3rd is day 62 in the year. Compounded until June 21st. So June 21st, right there, day 172. All right. So day 62 to day 172, that's what we're dealing with there. So problem number 3, here we go. Principal value, he deposited, Raul deposited $10,000. 5.5% interest. I don't know what their obsession is with 5.5%, but that's what we're going with. And then N, let's see, 172 minus 62 is 110 days. All right. Just double checking my previous notes that I've done, making sure this is all correct. Looks good. So 110 days between March 3rd and June 21st. Hey, that pretty much means by the time we get to the beginning of March, we only have like 100 days left in total in the school year. So not bad. That includes weekends. All right, so the amount, 10,000. That's our principal multiplied by 1 plus 0.055. 365 compounding periods in the year. 110 total compounding periods. So that'll give us the amount in the account, but we also need the interest after that. So let's go ahead and get everything plugged in here. 10 grand times all right, so we're looking at $10,167.12. So the interest earned over 110 days is $167.12. All right. I would like you to try the last one there, number 4. So use the table in Google Classroom. Determine how many days have passed between March 26th and July 24th. That's your value for N. And then use the value for P, value for R, formula, calculate the interest, all that good stuff. And I'm going to give you some time on this one. Let's say 3 minutes. So at 2:05, I'll check back in. a little bit more time to keep working on this. Just out of curiosity, how many days is it between March 26th and July 24th? Yep, somebody typed it in. That is correct. Anybody else? I bet Google or Siri could tell you that too, though. You might not need to use this. You can probably just ask a computer and it'll tell you, but it's kind of the easy way of doing it. Or Alexa for you Amazon users. Alexa could probably tell you as well. I've never used Alexa. I've definitely Google is the one that I go with most of the time. Actually, all of the time. Digital assistant wise, that is. All right. So I have one person who's answered the problem, and by the way, that one person is correct. So well done there. Does anybody else have an answer that they are willing to share? And you can share it directly to me as well. It's fine. It doesn't have to be publicly seen by everybody if you don't want it to. So I'm gonna unfreeze my camera here. All right. Cover up most of it though. So the principal value, $20,000. We know that. The R value, the rate that we're calculating is 5.5%, 0.055 compounded daily, so 365 compounding periods per year. And the N value, this is the one that we really had to figure out. There are 120 days between March 26th and July 24th. Actually, I'm going to ask Ian real quick. Ian, if you ask Google how many days are in between those two dates, does it tell you? Does it give it as 120? So if you ask Google how many days there are between March 26th and July 24th, will it tell you 120? I'm kind of curious about that. Just to see if we have to use that table or not. Okay. I'm curious. I bet it will. I feel like that's something that it would do. The dates are March 26th and July 24th. Yep, good. That's it. N equals 120. Cool. So if you have a digital assistant, you can ask it about the dates and it should give you that number instead of using the table. So that's just kind of a shortcut that you could use if you wanted to. Here's our equation then. So using our compound interest equation, we've got the amount is equal to 20,000 times, in parentheses, 1 plus 0.055 over 365, all to the 120th power. I miswrote my answer there, so I scribbled it out, and here's the actual amount. $20,364.91 after 120 days, which is essentially 4 months. About 4 months, so about a third of a year. So in that third of the year, you end up with $364.91 earned in interest. So not bad. I'm kind of curious though. Just that was the last one we're doing, by the way. I'm just wondering, what if it was there for the whole year? So over an entire year, you end up with over $1,000 in interest. So if you have $20,000 and it compounds the interest daily at 5.5%, you're going to get $1,130.72 a year in that first year in interest alone without adding any of additional money on your own. So again, kind of going back to yesterday, the sooner you can start putting money in interest earning accounts, the better. It's free money, which doesn't happen very often. All right, let's go take a look at your assignment and then we will call it a day. So taking a look here. It says use the amount of $1 at 5.5% compounded daily on table, page A10. Don't do that. Just calculate based on what we were doing. Just use the formula for all of these. So use the table on A10 to figure out the number of days, like on number 7 and number 8. But what it's saying up here about amount of $1 at 5.5%, don't worry about that. And then all these other ones, 5.5, 5.5, 5.5, everything's 5.5. Yeah. All right. Well, doesn't look like there's anything too crazy. 5.6, 20,000 compound daily. Yeah, that's what we're going to go with. So, yeah, work through that. This will be technically due tomorrow. I'll take questions tomorrow during class. I'll also be posting the unit review, like I said. We'll spend tomorrow, Monday, working on the unit review. Tuesday, you'll have the Unit 5 test posted as well, and you'll be able to work on that during class next Tuesday. So that is all I've got for you for today. We're out of here about 15 minutes early today, so that's good. I'll be posting this video a little bit later today as well, but yeah, we'll figure it out then, and I'll see you all right back here tomorrow at 1:32. Have a great day. Bye.